Look up tonight. The moon is there, pale, quiet, familiar. You've seen it your entire life and thought almost nothing of it. But for 99.97% of your ancestors' time on this planet, that pale disk was the reason everything worked. Your ancestors planted food by it. They crossed oceans by it. They counted years by it. Now imagine one night, it's gone, and in its place, filling the sky like nothing you've ever seen. Mars, red, massive, looming. What would that actually do to Earth? What would it do to you? The answer will permanently change how you look at the moon, and it begins with something nobody ever thinks to ask. Your first instinct is probably, that sounds extraordinary. An actual planet hanging in your night sky, close enough to see the dust storms, bright enough to cast shadows at midnight, more dramatic, more alive, more cosmic. That's what most would assume, but that's not quite right. Mars weighs 9 times more than the moon, 9 times. And when you multiply gravitational influence by 9 at the same distance, the consequences aren't just bigger, they're catastrophic at every scale simultaneously. So here's the question almost nobody asks. What invisible work is the moon doing right now that you have never noticed? Because until you understand what it's quietly doing, you can't understand what Mars would destroy. Let's start with the first thing Mars would shatter. The moon pulls on your oceans. You call this the tide, but the moon's deeper role, most have never considered it. In 2004, geophysicist David Rubincam at NASA's Goddard Space Flight Center published key research on gravitational stabilization. His findings: the moon keeps Earth's axial tilt locked between 22 and 24.5 degrees across millennia. That stability is the reason your seasons follow a predictable pattern. That predictability is why your ancestors could farm. That farming is why civilizations started. Now replace the moon with Mars. At 384,000 kilometers, at the moon's current distance, Mars would pull 9 times harder on every ocean on Earth. What this means for you is staggering. High tides wouldn't rise a meter or two. They would surge hundreds of kilometers inland. Every coastal ecosystem gone. Every river delta swallowed. Twice a day. Every day. Without stopping. Your ancestors survived because they never had to face this. You exist because of a moon that is exactly the right size. But it wasn't just the oceans that would shatter. Look beneath your feet. In 2016, planetary scientist Alyssa Rhoden at the Southwest Research Institute published findings in the journal Icarus. The research documented how massive tidal forces fracture the crusts of rocky bodies, the same process cracking Jupiter's moon Europa open right now. Apply 9 times the moon's tidal force to Earth's crust. The rock beneath every city would flex and groan continuously. Volcanic activity, not occasional, not regional, but global and perpetual. Earthquakes that don't stop between events because the source of stress never leaves the sky. The Yellowstone supervolcano, the Pacific Ring of Fire, the Mid-Atlantic Ridge, all of them responding to a gravitational pull that never lets the crust rest. What this means for you, the solid ground under your feet, is calm because the moon is small enough not to fracture it. Mars is not that small. But here's what's fascinating. That's not even the most dangerous thing Mars would do. Something deeper than the oceans would change. Your ancestors understood the moon's power without the mathematics. The word month is a linguistic fossil carved from moon, preserved in every language that organized time by the lunar cycle. The Babylonian calendar tracked the moon with obsessive precision, down to the minute. Your ancestors didn't just observe it, they built their entire conception of time around it. Because they understood, without knowing the mechanism, that the moon was the clock keeping the living world synchronized. Now imagine that clock replaced by something 9 times heavier, pulling 9 times harder. Would your ancestors have looked up at a red planet overhead and still felt wonder? Or would they have felt what that world would actually represent? A threat. But what really happens to Earth's spin when you add 9 times the gravitational weight overhead? That's where this gets genuinely terrifying. But here's the part nobody talks about. The tides, the earthquakes, those make sense. Any astronomer would mention them first. But there's a second consequence of having Mars as your moon that would doom every living thing on Earth, invisibly, quietly, over geological time. It's your planet's rotation. In 2019, astrophysicist Sara Walker at Arizona State University published research in the journal Astrobiology. Her work connected Earth's rotational speed directly to the stability conditions required for complex life. Here is what that means in practice. When the Moon formed 4.5 billion years ago, Earth spun once every 6 hours, 4 times faster than today. Over billions of years, the Moon's tidal drag slowed Earth down. Gradually, gently, precisely. That slowing is why your day is 24 hours. That 24-hour cycle is why complex photosynthesis became efficient. That efficiency is why oxygen flooded your atmosphere 2.4 billion years ago. That oxygen is why you can breathe right now. You've been told a day is 24 hours because that's simply how Earth is. But that 24-hour day is the Moon's gift, printed into your biology across geological time. Now replace the Moon with Mars. 9 times the mass, 9 times the tidal breaking. Earth's rotation decelerates dramatically, not over billions of years, but far faster. As rotation slows, Earth's magnetic dynamo weakens, and that magnetic field is the invisible armor around you right now. It deflects solar radiation. It keeps your atmosphere from bleeding into space. You know what a planet looks like without that armor? Mars. Mars had a magnetic field once. Then it faded. Then its atmosphere was stripped away by the solar wind. Then its water evaporated. Then it froze. And this explains why you exist today, and why Martian life, if it ever existed, doesn't. Your magnetosphere is Earth's immune system. A Mars moon would start dismantling it. Not in a week, not in a century, but the direction would be set, and the destination, a world that looks exactly like the planet now hanging in your sky. So what keeps Earth different from Mars right now? Now let's pause here for a second, because there's a layer to this nobody mentions. Mars comes with company. It has 2 moons of its own, Phobos and Deimos. If Mars replaced your moon, both of them would arrive with it. Phobos orbits only 9,376 kilometers from Mars's center, so close it's already being torn apart. In 2017, planetary geologist Thomas Platz at the Max Planck Institute for Solar System Research published analysis in Geophysical Research Letters. His findings: Phobos will be shredded by Mars's own gravity within 30 to 50 million years. So your sky wouldn't just hold Mars, it would hold Mars, Phobos and Deimos, 3 bodies in gravitational conversation directly overhead. The orbital mechanics become chaotic, unpredictable resonances, gravitational tugs in shifting directions, and evolution cannot work in chaos. Complex biology requires millions of years of stable conditions. But even after all those explanations, there's one thing that can't be fully accounted for: the tilt. In 1993, astronomer Jacques Laskar at the Paris Observatory published a landmark paper in the journal Nature. His finding: without the Moon, Earth's axial tilt would not stay stable. It would oscillate wildly between 0 and 85 degrees. 0 degrees means no seasons. Permanent heat locked at the equator, permanent ice everywhere else. 85 degrees means Earth tips nearly onto its side, like Uranus today. Each pole would bake for months in continuous sunlight, then freeze for months in total darkness. No stable climate belt. Anywhere, ever. And this is what your ancestors never knew they owed their existence to: a tilt angle of exactly 23.5 degrees, held constant for hundreds of millions of years by one small grey rock, circling at exactly the right distance. But even after everything, the tides, the spin, the magnetic field, the axial chaos, there's still one final layer. And it might be the strangest part of all. It's something encoded into your body so deeply that modern life has covered it almost completely. And what happens next changes everything. And then Mars arrived, not as your moon, but as itself, a cautionary mirror. For billions of years, Mars had everything Earth has now: liquid water, a magnetic field, an atmosphere thick enough to support weather. In 2021, planetary geochemist Ava Scheller at Caltech published research in the journal Science. Her findings showed Mars once held enough water to cover its entire surface, an ocean between 100 and 1,500 meters deep. Mars had coastlines, it had rainstorms, it may have had life, and then its magnetic field collapsed. Within what astronomers estimate was a few 100 million years, a geological instant, it lost everything. The word Mars in Latin means the god of war, the bringer of destruction. Not because of mythology, but because the ancient Romans, watching that red wandering star in their sky, felt something instinctively unsettling. Something aggressive, unstable, a threat. Your ancestors named it correctly without knowing why. Mars is what happens when the conditions for life slip just slightly out of alignment, and the only thing separating Earth from that fate, the only thing, is one small, unremarkable-looking moon holding everything in perfect, invisible balance. But here's what you actually lost: the ability to see that. This isn't just cosmic history. This is the architecture of your existence, running silently, right now. Every breath you take is downstream from the moon's gravitational influence. Your ancestors breathed that same air without knowing what was holding it in place. Your body evolved under a magnetic field, sustained by a rotation, maintained by a moon at exactly the right mass and exactly the right distance. Change any single variable, even by a factor of 2, and the chain breaks. And here's the part that cuts deepest. The moon is so familiar that your brain has stopped registering it. You've looked at it thousands of times. You've never once thought, that thing is why I'm alive. In 2014, astronomer David Rubincam at Royal Holloway University of London published Lucky Planet. His argument: Earth's habitability isn't typical. It's the result of an extraordinary sequence of near-impossible coincidences. The moon is the most important coincidence of them all. What if the moon isn't ordinary? What if it's the rarest configuration in the universe, a natural satellite of exactly the right size, at exactly the right distance, doing exactly the right work? Your body still responds to lunar light in ways you don't fully understand. Your sleep rhythms, your hormonal cycles, your circadian architecture, all calibrated against that pale disk over millions of years of evolution. Your body still tracks it. It just doesn't know why. For every generation of your ancestors, the moon was the most important object in the sky. You might be the first generation that forgot, and you have no idea how rare that forgetting is. So here's what the Mars thought experiment actually reveals. If Mars hung where the moon is, the tides would tear your coastlines apart. The crust would crack open beneath you, the magnetic field would fade, the atmosphere would bleed into space, and the axial tilt giving your seasons their rhythm would swing wildly, erasing the climatic stability that let your ancestors plant the first seed. None of that happened, because of one small, grey, unremarkable-looking rock. The paradox is this: the most important object keeping you alive right now is the one you look at and feel nothing. You traded wonder for familiarity. You traded reverence for assumption. Your ancestors looked at the moon and built entire civilizations around its constancy. The moon hasn't changed. It's still doing the same impossible work it has always done, holding the tides, stabilizing the seasons, protecting every living thing that ever drew breath on this planet. You just stopped noticing, and that might be the strangest thing Mars never had to destroy, because you did it yourself.